All right, today we're talking about mixture problems. So what the heck does that even mean? This is a kind of the first introduction to modeling with differential equations that you see for using first order linear ODEs. Okay, so what's the overall setup? Classically, the setup is kind of the following. So you imagine you have some sort of vat, some sort of container, something like that. You can think about it as like just a water tank is what we're going to basically use it as. Okay? And you're going to imagine that you have some sort of fluid coming into it. So we'll think about it as like salt water, for example. And then potentially I can have water leaving the tank at certain rates and things along those lines. Okay? So the idea is that coming into it, I'm going to have some sort of rate in, okay, which we're going to call RIN. And the rate is just telling you how much fluid is coming in per unit time. So we'll say this is like rate in is going to be in liters per minute, okay, just for this example. And then whatever the fluid is that's coming in, it's got a certain concentration of the amount of whatever we're interested in. So we're going to have the concentration in, CIN. What is that going to be? That's going to be the concentration coming into it, and that's going to be measured in terms of, it's concentration, so it's an amount per volume. So this will be, say, grams per liter, something along those lines, okay? So this would be my concentration. Okay, that's my concentration in. That's coming in. Now, I'm also going to have fluid leaving potentially. So I'm also going to have rate out. Okay, so that's R out. Again, that'll be in what? Liters per minute in this example. And then I'm going to have a concentration out. So that'll be C out. And that'll be in terms of what? Well, that'll be in terms of, again, grams per liter. And I'm going to assume that as the water comes in, or whatever the fluid is that comes in, I'm going to say that it's kind of instantaneously mixed, okay? So it's not like, you have like a glass of water and you like put a droplet of like food coloring in it. You kind of see it like float through the water, and then eventually it kind of hits the bottom and starts to diffuse, but the top of the water is still pretty clear. We're kind of imagining that as I drop that food coloring into the water, instantly the water is just completely that color, okay? So that's kind of the idea with the instantaneous mixing, all right? And then we're going to say, like, let's say x of t is the amount of whatever the material is. In this case, let's call it salt, okay? Amount of salt in the tank at time t, okay? So we're going to have x of t is the amount of salt in the tank at time t. And then let's say that initially the volume, okay, something like this. Let's say we have initially, we have the tank is 200 liters of pure water, okay? Of pure water. We want to know something like, what is the differential equation which is going to model the flow of salt coming into the tank at time t? Okay, that's the idea. So the question is, what is the model? What is the ODE modeling amount of salt in the tank? Okay, that's what we're trying to figure out. Okay, so let's think about this for a second. Well, one thing we can say is, I'm interested in an ODE, so I want to know the rate of change of salt in the tank at time t with respect to time. So I could say something like dx dt. Okay, so what is that? Well, what are the units? Okay, what are the units? Well, the units for x, in this case, that's the amount of salt, and we're measuring that in grams. Okay, so what are the units here? This would be grams per time, which we're saying is minutes. That's grams per time. Now, what I notice is, look, if I take the rate in times the concentration in, what are their units? I get liters per minute multiplied by grams per liter. The liters cancel, I'm left with grams per minute, and that's precisely what I get here. So what I notice is that the net influx will be rate in times concentration in minus the rate out times concentration out. Okay? So that's going to be our ODE. Now, when you look at this, you're like, okay, well, I see a first order ODE here. That's great, but I don't really know if it's like, is it linear? Is it like, what is it kind of thing? Well, what do we know? Rate in, concentration in, those are just numerical values typically, okay? But rate out, that's also a numerical value. Concentration out, though, what is that going to be? Well, the concentration out is going to be what? It's the amount of salt in the tank. Well, we don't know what that is. That's x of t at any given time t, divided by the volume, and the volume might be changing in time. So that could potentially just be v of t. Okay, so if I plug that in, I'm left with dx dt is equal to rate in, concentration in, minus rate out times x of t over v of t. Right? So now if I just kind of move this over, I can say that I get dx dt plus rate out times x over v of t, okay, equals rate in, concentration in. And I recognize this immediately as a linear first order ODE. Okay, now depending on the context, like they're going to tell you things like what is the rate in, the concentration in, what's the rate out, things like that. You could say like 5 liters per minute are coming in, but then only 4 liters per minute are leaving the tank, so that the volume is increase, or is, let's see, 5 coming in, 4 going out. That means you're getting 1 net increase every minute, kind of thing. So V of t would be increasing by 1 every time step. Things along those lines. These are the smaller nuances on how these things work, but overall I wanted to just give you an overall setup of how do you look at mixture problems in terms of ODEs and what is the first order linear ODE modeling these particular mixture tanks. Okay, so we're going to do a bunch of examples on these things in other videos, so don't worry about that. But if you have any questions, you have any comments, you want to understand these a little bit more, you have questions you want me to work through, put them down in the comments. Again, like, subscribe, all the things, and we'll keep moving.